So please picture yourself as an engineer in a major security assessment company 20 years ago. And this was your world. You had servers sitting in a dark and cold server room with a hardware, CPU, memory, disk, operating system connected to the network, and you need to assess them. You don't have a lot of options. One option, the most trivial one, is to go from the network, send packets, authenticated, unauthenticated, etc., get the responses, and by that, building the security posture. Other option is to install security agent. The agent will read the data and will report it back to the mothership. If you think about it, these are your options. You are bound by that. You can't do anything else. This is a server in a different room. So all of these companies that are in fact founded more than 20 years ago created these solutions, network scanners, authenticated, unauthenticated, agents, and have been selling them for the last 20 years. But things have changed. The rule of the game have changed, and they haven't noticed it. And as Abba Master once said, if everything that you have is an hammer, then everything looks like a nail. When the cloud arrived, they simply took the same approach with its cons to the cloud without noticing that there is a better way. If you look at it, virtualization came afterwards. I know it's ancient history by now, but when security assessment started, virtualization wasn't a thing. Shortly after virtualization came the concept of virtualization clusters. Why should I care on which physical machine my workload runs? Let's just treat a bunch of physical servers as a shared pool of resources. But there was one issue. If you simply take many commodity servers and make out of them a shared virtualization cluster, then when you need to scale up, take a machine out, etc., it's slow because it sits physically on one disk.
Avi, on this slide, what are these spinning boxes on the bottom here? What are those representing?
So think of them as the virtual machines that needs to move between servers.
Okay.
That when you scale up and down, you need to copy and move the virtual machines between the physical servers, which is very slow. So therefore, the architecture evolved. And if you go to a modern data center, you won't see commodity servers with disks on them, but you'll see a separation of the storage from the compute. And this is one thing that you need to understand. There is a different server with the block storage and other compute servers connected via high-speed fiber optics. Okay, and this means different rules for the game for security assessment. Because if you go and fast forward in time, this architecture became more and more capable, and the cloud providers are using more and more capable hardware to perform this multi-tenant virtualization. And what we are doing, and this is the unique part about our technology, we run on the same data center via APIs and read the same data that the workload reads. Think of it as if in the 20 years ago, you had another interface in each server that the scanner had a magic cable connected to it. And this interface allowed you to read everything. And this is exactly what we have currently. These disks are not physical disks anymore. These machines are not physical machines. They are virtual entities that are provisioned on a virtual data center. And therefore, you can read them from the side or from the bottom, depending on the way that you want to picture it to self. But we are reading them without the operation system involvement, without anything on its behalf. And this is why we are completely VPC agnostic. We don't need credential, and we can reassure you that we'll scan anything. And Ben,
so I'm confused, Avi. When I look at this slide, if you can just go back one to make that bigger there. So is Orca installed by the cloud provider? How does it get integrated with these multi-tenanted company B and company C so it can look at their stuff? It looks like they're all in one box here. How does this get glued together?
So thanks for the question. In fact, think of the yellow red part as the virtual part. Physically, Orca runs on the same data center like the customer workload. This is critical for performance. It would never be possible if we ran in a different data center. But logically, it's a SaaS server. It's delivered as a complete SaaS service, that is getting permissions to the customer environment. All the customer needs to do is to follow a short 3 steps integration to allow Orca to read its workloads, and then it behind the scenes launches a virtual scanner that reads the same data that the customer doesn't need to manage, doesn't need to do anything about. We simply do it for him. So
So,
physically, we are in the same data center, logically a SaaS service.
so this SaaS service, is it sort of accessing the same underlying data as company B and company C here, but out of band without affecting their performance?
Exactly. Yes, we are reading the exact same data from the side, and it's not the initial images. I'd like to emphasize it's the runtime data. If a bit changes, we see it. If the byte changes, we see it. Now, regarding the performance, this is indeed something that many people are concerned about. But if you think about it, these disks are not physical disks. You're not bound by the physical hardware of this block device. These are provisioned entities that also have the performance characteristic provisioned. So when the customer launches a workload and asks for, let's say, 1,000 IOPS, and we launch a different scanner and ask for another 100 IOPS for the terms of the scan, it doesn't take from the customer performance metrics. It's simply additional performance metrics. You're not eating the actual Amazon data center performance limits. And we tested.
So it's almost like if someone had mental telepathy and they could read someone else's mind, they wouldn't slow down that person's mind by reading their mind, because they would the person who has the ESP would be using the processing of their own mind when doing that.
Yes, you're correct, and I can also testify that we tested it in the most extreme conditions of workloads that 100% of the time just changes random data with CPUs working for 100%. We haven't managed to measure any performance impact. And this is also possible due to improvement that the cloud providers have done on their end in the last 1 or 2 years.
Interesting. Continue.
So essentially, if you think about it, this provides us a really unprecedented access to data with seamless integration, which is the holy grail of security assessment. You want to see everything seamlessly, and this is the way. We see every bit and byte of the system together with the cloud configuration that allows us to make it in context. We see those binaries, the configuration log files, all of the installed application as well, binaries, configuration logs, the business data on files and databases, and we're able to scan recursively into containerized environments. So if you have containers, we simply scan them, again, from the virtual hardware side. And another cool thing, this is a much better place to do security because we do not run on the same machines that we assess. So if, let's say, there's a rootkit or a very capable malware that tries to attack the security mechanism, it doesn't affect us because we don't run on the same machine. So this is another cool side value of that.